Section 1.4 is titled Measuring Angles. The objective today is to find and compare the measures of angles. Today we have to copy postulate 1.7 and postulate 1.8. So before today is over, make sure that you have both of those in your separate notebook, and I will tell you what you can have when we get to them. So today we're going to talk about angles. Notice we have 3 points on this angle. We have point B, point A, point C. When you're talking about a little bit of vocabulary, the angle can be named in a number of different ways. The angle symbol that I used is one that looks like an angle, and I usually put an arc through it. You can do either one of these. An angle is formed by 2 rays with the same endpoint. So on this one, the 2 rays that we're talking about would be ray AB and ray AC. Notice that the starting point for each of those rays is point A. That's the vertex. So point A is the vertex because each of the rays start with A. Here's the number of ways that you can name this angle. You can name it angle A. The letter that you pick, if you use a single letter, has to be the vertex. You could name it angle BAC. The vertex has to be in the middle. You could switch those letters around and do CAB. The A has to be in the middle. Or sometimes they put a number inside, and you can name it using the number as well. Just to verify again, when you're naming an angle, if you're using 3 points, the vertex has to be in the middle. Let's take a look at problem number 1. What are the 2 other names for angle 1? So first of all, angle 1 is this one. On this one, you cannot name it angle M because angle M is the whole entire thing with 1 and 2 together. So 2 names for angle 1. I'm going to start with J. The vertex has to be in the middle. And the other one would be switching those letters and starting with K. The vertex has to be in the middle. Why is angle JKM not a correct way to name angle 1? Well, J to K skips across it. You have to actually follow the angle. So you're going to go this way and that way. The vertex must be in the middle. Which point is in the exterior of angle 1? So when we look back at this one, the exterior, now when you're looking at interior and exterior, right here is interior. And this right here is exterior. So if you're looking at angle 1 goes here, and then anything out here would be the exterior. So let's see, JMK. So anything that's on the outside of angle JMK, I'm going to say point L. You can't say M because M's on the angle. You can't say J or K because they're on the angle, and you can't say anything on the inside. You can pause the video for a minute and try got it question number 1. Okay, so here's the picture one more time. The other one has a lot going on. So this one right here is J, M, K, and L. So what are the 2 other names for angle KML? That's this one. There was a 1 here and a 2 there. So KML goes from left to right. You could name this one angle 2. You could also reverse the L and the K around and name it angle LMK. Would it be correct to name any of the angles angle M? I'm going to say no this time because point M belongs to too many things. Okay, for example, angle JML would be the whole entire thing. Angle JMK would be the angle 1, and angle KML would be the angle 2. And if you named them angle M, you would not know which one of the three you were using. So when you call it a one-letter angle name, it better be the only name that you can use. Postulate 1.7. Make sure you put this into your postulates and theorems. It's called the protractor postulate. Every ray can be paired one-to-one with a real number from 0 to 180. So I have a picture of a postulate or a protractor here. Notice that there's a dot in the center. That's going to be where your vertex of your angle is. Okay. Then notice that there's numbers on the inside that go from 0 to 180 going this way. And there's numbers starting on the left side that go from 0 to 180 that way. So really it depends on, how you have your protractor on your paper, but make sure you're always going from where 0 starts. So if your angle was here, let me do that in a different color just a second here. If you had an angle right here, okay, this is where the angle starts. So that would be where your 0 is. Okay, I would use this one because it's going off to the right. If my angle opened up to the left, I would use the 0 on the left side and the outside numbers. So for this one, I would call this one about 34 degrees. And I just hand drew it, so it's not very good. But when you're making angles or drawing angles, you should always use a ruler. Let's see if I forgot anything there. If you look in the book at their protractor, when you're looking at the bottom of page 28, one thing that I do a little bit differently than the book does, if they actually have a protractor drawn on there for you, you have to do kind of what the book does. What you would do is you would find out where that ray OC is, and you would write that down. You'd have to find out where that ray OD is, write that down, and then subtract the two. Okay, if they don't have it drawn on there for you, you can always line up wherever that ray OD is, and that could be your 0, and you could just measure it from there. We'll talk about that in class tomorrow. There are 4 types of angles. You guys already know these, maybe not the straight one, but an acute angle is one that is between 0 and 90. Now, by between, I mean it can't be 0 and it can't be 90. A 0-degree angle doesn't make sense, and a 90-degree angle is something else. A right angle is exactly 90 degrees. An obtuse angle is between 90 degrees and 180 degrees. It can't be 90 because 90 is a right angle, and it can't be 180 because that's something else. A straight angle is exactly 180 degrees. Okay, so make sure that you know all those. You shouldn't need a picture or anything of those, but if you need one, you can draw one into your notes if you'd like. Problem 2, what are the measures of angles LKN, JKL, and JKN? Classify each as acute, oops, I spelled that wrong, add a T in there, right, obtuse, or straight. So let's start with angle LKN. Okay, so LKN. Since the protractor is on top of the picture, we have to just go with what we see. For LKN, this right here, I'm going to just go right over it with the color that I'm looking at. Okay, so this one's the green. Since this is already on top of the 0 degree line, we're going to use those numbers on the inside and go all the way up to what we need. Notice it is an obtuse angle because it's bigger than 90, and it is going to be 145 degrees. Okay, let's go with angle JKL. Okay, so JKL, that's this one. So notice that ray KJ is at 90 degrees. Ray KL is at 35 degrees. This is an acute angle because it is less than 90. This one's at 35, and we're going to subtract. So 90 subtract 35 will be how much this one is. 55 degrees. Okay, and then they have one more. Let's go with purple. JKN, so JKN, that's this one. Notice that KN follows the 0. For this one, we'll also go counterclockwise. So angle JKN equals 90 degrees. We'd say 90 degrees, subtract 0, which is 90, or just look at it and it's a right angle. And this one is right. So don't forget to classify as right, obtuse, straight, or acute. How could you measure an angle if the rays were not long enough to intersect with the scale on the protractor? Extend the lines. Or I shouldn't say lines, I should say rays. Until it intersects the protractor. Never, ever guess. Always extend. So you can pause right here and look at question number 2. They are using the exact same protractor as they were before. So we're going to go with LKH. So LKH opens to the left. So I'm going to use the numbers on the outside of my protractor. I'm going to use these. So it goes from 0 to 35 degrees, and it is acute. So I'm going to say 35 degrees acute. Okay, angle HKN. So HKN goes from the left side of the protractor to the right side. That means it goes from 0 to 180. So it would be 180 degrees, and that is a straight angle. And then angle MKH. MKH. Since one of the lines intersects 0, we'll go use all the numbers on the outside to get to the M. So 0 to 145. So 145, and that would be obtuse because it's bigger than 90 and less than 180. So next we're going to talk about how you know if angles are congruent. Congruent angles are angles that have the same measures. So we have an angle A and an angle B. These little hash marks here indicate that those angles are congruent. We don't have to know how much they are, we just know that they're the same. You're going to get a variety of pictures where they'll have different angles marked. Sometimes they have single hash marks, sometimes they have double hash marks like this one. Those would be congruent as well. If they have something like this, those are not congruent because they don't have the same markings. So you're basically looking for the same markings in those angles. Remember that the measures of the angles are equal, but the angles are congruent. Measures are equal, angles are congruent. Can you go by visual inspection or a protractor to determine if two angles in a diagram are congruent? No. Do not just look at and assume angles are congruent. Basically, they must be marked congruent. Or directions must say that they're congruent. You'll never want to do a protractor because the pictures in the book are very, very small. And they use them over and over and over again. Unless it tells you to measure. Okay, so a little tiny picture in one of them might be 30 degrees. Another picture, they could use the same picture and say it's 45 degrees. So never use the protractor, never just look at it and assume that they're equal unless they have the little hash marks or it says it in the directions. Problem number 3. So we have some synchronized swimmers. They form angles with their bodies. It says if angle GHJ, that's this one, is 90, what is the measure of angle KLM? That's this one. So if you're looking at markings, GHJ has double hash marks. And when you look at angle KLM, that also has double hash marks. So they both must be 90 degrees. You can pause it and work on got it question number 3. It says if angle ABC equals 49, what's DEF? So angle ABC, it's this one. That one has a single hash mark. What is DEF? That one also has a single hash mark. So that one also equals 49 degrees. Postulate 1.8. copy this into your postulate and theorem notebook. It's called the angle addition postulate. Another abbreviation for that is AAP. If point B is on the interior of angle AOC, that just means inside, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So I wrote that out in words. I also wrote it out using the letters and the picture as well. So basically it's the yellow part plus the blue part, and that equals the whole entire angle. It's kind of like the segment addition postulate that we did earlier. Now let's learn how to use that. If the measure of angle RQT, oops, this is a Q, is 155, so this whole entire angle measures 155, what you're going to do is you're going to break it down into the two parts, RQS and SQT equals the measure of angle RQT. Okay, so if we substitute each of those parts in, the measure of RQS is 4x minus 20. The measure of SQT is 3x plus 14. And in the directions, it told us that RQT is 155. So we'll put like terms together. The x's would make 7x. The numbers would make a minus 6, because negative 20 plus 14 is minus 6, and you get 155. So we'll add 6 on this part to both sides. So you get 161, and 161 divided by 7 is 23. Okay, so here we divided by 7. So now it says, what are the measures of angle RQS and TQS? So RQS would be 4 times 23 minus 20, which is 72. And the measure of angle TQS or SQT would be 3 times 23 plus 14, which is 83. Now, if we add those two together, 72 plus 83 equals 155, just like they said it did. So that one does work. So looking at the questions, I'm going to see that we answered everything. What algebraic expression represents the measure of angle RQT? That's this one. What kind of angles are RQS and TQS? Well, RQS is 72. TQS is 83. So those are both acute angles. Because their measures are less than 90. You can pause for a minute and try got it question number 4 and come back and check yourself. So angle DEF is a straight angle. Okay, right there, we know that that equals 180 degrees. What are angles DEC and CEF? Okay, so measure of angle DEC plus the measure of angle CEF equals measure of angle DEF. If we plug in each of these things, DEC is 11x minus 12. CEF is 2x plus 10, and those two parts added together should equal 180. Putting like terms together, we have 13 x's. A negative 12 plus 10 would be a negative 2. So we will add 2 to both sides. 13x equals 182. And then we will divide by 13. So x equals 14. Again, they're asking for the measures. So what we would do is we would take 11 times 14 minus 12 and 2 times 14 plus 10. So the measure of angle DEC is equal to 11 times 14 minus 12, 142. And that does make sense because it looks like an obtuse angle. And then the measure of angle CEF would be 2 times 14 is 28. 28 plus 10 would be 38. And if we add the two together, they should equal 180. So 142 plus 38 does equal 180. So we should have it. Okay, which is what it told us to do. And that is it. So we will go through any questions that you guys have tomorrow in class and also do a little bit more practicing.